this is a very important point, okay? That the cyanide on complete hydrolysis will become carboxylic acid. Fine, children? It's going to be useful in a number of places. Cyanide on complete hydrolysis will become carboxylic acid. Okay, Aprameya? And in between, as you continue to do, you remember this will be somewhere in the fourth lesson or third lesson. In between, cyanides can be partially hydrolyzed to amides, and full hydrolysis gives carboxylic acid. Okay, so remember this in a very, very different manner, because it is going to help you in a number of ways. Okay, so assume that you want to make aniline. Okay, I'll complete this work because I thought I'll start writing iodobenzene. I'll give you some conversion questions straight forward to you. But currently we will go to the text. We were having this same first lesson, some more questions to do, correct, Aprameya?
Yes, ma'am. We had like
A
in
lot
the
actually,
conversions we had a lot, and
a
then
lot. But I was telling you that I'll record and send, but I'll try to do some here. Okay,
yes, ma'am.
some of them, so that you get an idea. Okay, so let me try.
Some of the questions you marked it, and we were supposed to do it on our own.
Uh,
Those were like I can tell you the numbers if you.
Tell me.
Yes, ma'am. So seven. And then the first two you said we can do it in our leisure time. Seven,
Hmm. Hmm.
9, and then 16.
Okay.
And then in
I'll
14 you did
huh.
some. Uh,
14th, this one.
14
14th,
you did some of it.
but we
And then
did that day. 14th we
yeah,
did
yeah,
that day.
14 we did. So
Okay.
we did 3, 5, 6, 7, and 8 and 14.
Okay. And whatever I do, no, if I continue to do so, I'll prolong this lesson only. Okay. Instead of that, as I said, parallelly, you people also will start. Okay. Right. So the first question, it's propene to propanol. Propene to propane 1-all. Fine. So I think this we did. This we did, ma. Butane, remember 11th standard reaction,
Yes,
Abdin.
ma'am, we did.
We
We
did,
did
we did.
some, but then we had a
We
lot
did
of them.
some. Huh. This fifth question. I think fifth question, I was telling you that fifth question also we did. Benzene to 4-bromo-nitrobenzene. So it is benzene to 4-bromo-nitrobenzene. 4-bromo-nitrobenzene. It's not like that you have to write bromine down. You could have written bromine up and nitro down also, because it is relative position. Okay, so it's 1, 2, 3, 4, or 1, 2, 3, 4. Both are fine. So in this case, there is an electron withdrawing group which directs the incoming electrophile to meta. There is an electron donating group which directs it to ortho and para. Do you remember this case, Aprameya? So whether we will
Yes,
introduce the electron donating group first, should we introduce the bromo group? And if I do the nitration, so how will you introduce bromine Br2 in the presence of
FEBR.
FeBr3? And if I do that, I'll get the bromine, no problem. But next, when I do the concentrated H2SO4 and HNO3, which is for nitration, that the bromine group, since it is electron donating group by plus R, will ask the incoming electrophile at the para position. So you are going to get the para. Yes, Prajesh, is that fine? These concepts
Yes,
were
ma'am.
from 11th standard. These were from 11th standard. Okay. Okay. Supposing I tried to do the nitration first. That means same nitrating agent I will add. Concentrated HNO3 and H2SO4. Then it introduces the nitro group first. But that nitro group will allow the next Br2 FeBr3 will provide you a bromonium ion, which will now go to the meta position, because nitro group is an electron withdrawing group. So it will go to the meta position. So I don't get, or you don't get what you needed. You will be getting what you like, no, you will be getting a meta product. So I will be getting 3 bromonitrobenzene instead of 4 bromonitrobenzene. So which is not a desirable one. So the best one will be to first to do bromination and then do the nitration. Clear? Not the nitration and then followed by bromination. Is that okay? Both of you?
Yes, ma'am.
Hmm? Okay. Next one will be this. This is where you will use that case mark, cyanides on complete hydrolysis. Look at this part. Sixth one is benzyl alcohol. Again and again, we have been focusing on benzyl, C6H5CH2OH is benzyl alcohol. Okay, now a lot of people will put benzyl, benzene, alcohol, உடனே phenol தூக்கி போட்டு இதுதான் benzyl alcohol and mistake பண்ணுவாங்க. Please don't do that. Fine, children? Now this is benzyl alcohol to 2-phenyl ethanoic acid. So how to write the structure? Start from the last, ethanoic acid. So it is a 2-carbon carboxylic acid. This is first carbon, this is second. On the second position, we have got a benzene. Is the structure first clear to both of you? 2-phenyl ethanoic acid. Is the structure clear? Okay, looks like this segment is directly there. You need to introduce the COOH in the place of OH. Yes, Aprameya?
Yes, ma'am.
So can it be something like you do retro work? Retro means go back and think what it should be. So can we think that had this been a CN, after CH2, if there had been a CN, we could have done complete hydrolysis to get a carboxylic acid. Just now we saw one reaction. Cyanide on complete hydrolysis will become carboxylic acid, right? Yeah. So can we use that here? So our objective will be to introduce in the place of OH a cyano group. How do you introduce that? Is a direct reaction possible or indirectly it is possible? Think. Is it directly allowed to replace the OH with the cyanide? OH is never a good leaving group. So what you will do? You will take it, you will use SnCl2, sorry. You will use the, what happened, Pranav? Pranav? Pranav?
Yes, ma'am.
What happened?
I'm sorry,
You're,
ma'am. I was in the middle of a test, ma'am.
okay, fine. In that case, you drop a message, I'll start recording the class.
Yes, ma'am.
Okay. Okay. So first thing, OH is never a good leaving group. Okay. So you cannot replace it with a cyanide. What we have seen is if you have got an RCl, then we can treat it with alcoholic aqueous KOH, a mixture of alcohol, aqueous KCN will give you the cyanide ion, which will do the substitution. You remember? You remember, children?
Yeah.
But cyanide is never going to replace an OH minus. Cyanide will never replace. Please understand that. Okay, so instead what we will do, we'll first convert it to alkyl halide. Once it is alkyl halide, then we will bring the cyanide ion. Aprameya, is the strategy clear?
Yes, ma'am.
Okay, so what we will do, we will introduce SOCl2 or ZnCl2HCl or any of the halogenating agent and convert it into benzyl chloride or bromide, whatever you like you do. And then you treat it with the KCN in alcohol aqueous medium. Cyanide will go and replace. Once you have attached the cyanide, you can completely hydrolyze the cyanide to give a carboxylic acid. Pranav, is that clear? I have put the
Yes,
starting material, benzyl alcohol, and this is 2-phenyl ethanoic acid. Okay, 2-phenyl ethanoic acid. So we are attaching, we learned one reaction that if you have a cyanide, If you do partial hydrolysis, you get an amide. If you do full hydrolysis, you get a carboxylic acid. So I want a carboxylic acid. So before being that, it should have been a cyanide. Because in this particular lesson, have we seen any reaction in which you are getting carboxylic acid? No, na?
No.
No. Adanalda, I'm helping you out with this reaction. Cyanide on complete hydrolysis will become carboxylic acid. So once you need 2-phenyl ethanoic acid, we will use the COOH. How to bring that? We will use a cyanide in the place of that COOH. If there was a cyanide, you can do hydrolysis to get a carboxylic acid. Now, how to introduce a cyanide? You cannot introduce a cyanide on alcohol. You can introduce cyanide on an alkyl halide. So convert first the alcohol into halide and then convert halide into cyanide into carboxylic acid. See what you should do. No, I am giving you ideas now. I am giving you the results. Now you have to think it this way. Oh, this is how it is being done. Oh, if I have to do this from this to that, oh, this is good idea. See, you should start appreciating. You should start collecting ideas and you should shut all of this and go to the questions fresh and start working on it. You have to collect ideas. You shouldn't memorize. Oh, ma'am told benzyl alcohol to 2-phenyl ethanoic acid. This is the way it is to be done. It's not like that. You shouldn't memorize. Okay, got that, children? You should start collecting ideas. Oh, நம்மளுக்கு இங்க என்ன இருக்கு? C6H5 CH2OH. Whereas here the end product has got C6H5 CH2 COH. Appo how to introduce a carbon? Oh, maybe as a cyanide. Then cyanide can be hydrolyzed. Okay. Now I'll give you one question. Please think about it. I've got phenyl, that is benzyl alcohol, and I want to make it phenyl ethane or ethyl benzene. Come on. Think about it. In the place of OH, this part is common for both the compounds. I want O in the place of OH, one CH3. What can we do? Think about it. Anybody can tell me. Start collecting ideas. If you want to extend the carbon chain Woods reaction, or you can do it by organometallic compound, Grignard reagent, think in that lines also. Not striking? Could it have been something like this? See, CH3Cl, simply CH3Cl in the presence of 2 moles of sodium. Will it not
Yes.
work? Correct?
Yes, ma'am.
Or if you don't want mixture of products, you can take CH3 minus MgBr plus. The CH3 minus as a nucleophile goes, attacks, sorry, this is CH2, attacks the CH2 and removes the chloride. Methyl group takes its place. So will we not get an ethyl carbon chain here? Yes, children?
Yes, ma'am.
Okay, so once again, the methyl anion will not, that is from the Grignard will not approach an alcohol. Remember something there. If Grignard is given any compound which has got acidic hydrogens, okay, that can be water, that can be alcohol, or that can be an amine, then it gets hydrolyzed. From alcohol, what will happen? You will get, say, CH3, CH something, okay, whatever you have, say CH3OH. Then the anion will grab a proton from this protic alcohol and become a methane. So you can't use Grignard over an alcohol. What do? Convert this alcohol into an halogen. So again treat it with SOCl2 or ZnCl2, HCl and so on. Is it clear?
Ma'am.
Okay. So see, grab ideas. I'm saying don't memorize. Are you going to get these conversions? No. But are you going to get similar conversions? Yes. So start getting ideas from these conversions. Clear, ma?
Yes, ma'am.
Seventh one. Okay. Seventh is ethanol to propane nitrile. Ethanol CH3, CH2OH to propane nitrile. What is propane nitrile? In nitriles, the nomenclature goes by the total number of carbons. So CH3, CH2, CN. Propane nitrile, 3 carbons, 3 carbon nitrile. So obviously it looks like the OH. This much is there in both of them. OH has been replaced with the CN. Yes, Aprameya, can you think and tell me what is happening? Simple case, na?
Yes, ma'am. We can do the partial hydrolysis.
That is done on a cyanide.
Oh, sorry.
Hmm. We have to replace OH with a cyanide.
Yes, ma'am. We can first convert it to like CH3, CH2Cl, and then do it.
Yeah. So SOCl2 or ZnCl2HCl and then go for KCN in the presence of alcohol. A CN minus will replace the chloride, nucleophilic substitution. Yes, Pranav, clear? See, it is from here only, na? See, you had an OH and you want in its place CN. Is it not almost the similar one? Yes, Aprameya? Is
Yes,
it
ma'am.
clear? Okay. So start collecting ideas and then close everything. All these help that you have, no, like the answers. Are you noting down all these things? Shall I do it on a PPT and share it with you? It will save your time also.
Ma'am, I'm noting it.
Yes, ma'am.
Noting. Prajesh, what about you?
Yes, ma'am.
Doing it? Are you writing parallelly?
No, I'm going back home, ma'am.
Okay. I'll write it there.
Thank you.
Hmm. Okay. What is the PPT? Okay. So we are doing this. This is one over. The seventh one is over, right? The seventh is currently over. So what you will do? We will take CH3, CH2OH, and you wanted to make it into a 3 carbon cyanide. So CH3, CH2, CN. So first replace this OH with a very good leaving group. Make it into CH3, CH2Cl, and then treat it with KCN, aqueous or alcoholic. Alcoholic is better. Okay, then next one. Aniline to chlorobenzene. Aniline to chlorobenzene. Yes. Is this not an application of Sandmeyer's reaction, children? what do you have to do? First do diazotization, NaNO2 and HCl, and you make it into benzene diazonium chloride. All this is there in your text. I'm not coining anything new. So benzene diazonium chloride, and then treat it with Cu2Cl2 in the presence of HCl. Is this not Sandmeyer reaction, children? Correct? Should I show you? Let it come. We'll go to the next one. I'll show you those things. Okay. Is that fine? Aniline to chlorobenzene is fine, children? Aniline to chlorobenzene.
Yes.
Hmm? Okay. Here you must have the Sandmeyer's. This was nucleophilic substitution. Somewhere here you must have the electrophilic, the Sandmeyer's reaction generating iodobenzene, bromobenzene, though this one. So first thing, aniline is converted to benzene diazonium chloride. Benzene diazonium chloride in the presence of Cu2X2. That can be Cu2Cl2, Cu2Br2 is converted to C6H5Cl or Br. If you want to bring iodine on it, then use the benzene diazonium chloride directly with Ki, you will get the replacement there. Okay, so this reaction. Okay, when did we agree to have a test, children, from this lesson? Ninth one is 2-chlorobutane. This is 2-chlorobutane. To 3,4 dimethylhexane. Hexane is a 6-carbon hydrocarbon. First, second, third, 3,4 dimethyl. See, whenever you see such cases, see how many carbons are there in this? Totally 1, 2, 3, and 4. And if you take the product, it's looking like 1, 2, 3, 4, 5, and 6, 7, and 8. Does it not look like a 4-carbon compound is becoming 8-carbon compound? So is it not looking like doubling up the alkyl carbon chain?
Can we do the NABR reaction?
NABR, or what reaction? What is the name of that?
Sorry, Mar.
You want to join R with an R, right?
Yeah.
What is that reaction in which R is connected to R? Isn't it Wood's reaction?
Mar.
So what do? Assume that you have a chlorine here. Similarly, you take another one. Chlorine. You use 2 moles of sodium. Pick the both the chlorines. Okay. And you connect this carbon, third carbon, with this carbon, third carbon. Okay. So this is your third carbon. Third carbon seems to be having a methyl group. So third carbon seems to be having a methyl. In this section also, third carbon seems to be having methyl. So this side, third carbon seems to be having a methyl. So is it not looking like a Wood's reaction product, children? Are you able to understand this? Yes, Pranav and Prajesh? Should we write again? See, if you want to understand this part, if you have CH3, CH2, CHCl, CH3 is the starting material. And they are saying you want CH3, CH2, CH, CH3 joined to CH, CH3, CH2, CH3. So can we put it like this? The methyl group on top, the chlorine right side, and use 2 molecules of the same molecule type, CH, CH3 and Cl, and use 2 moles of sodium to pick the 2 chlorines and connect this carbon chain with that carbon chain to get this product. Is that making sense? Is that okay? All three of you?
Yes.
Yes,
Hmm?
ma'am.
Okay. The next one, 2-methyl 1-propene. It's 2-methyl 1-propene. Okay. To save the time. See, how many of you are interested in NEET here? Apramya, any idea? NEET. I think Pranav is doing JE only.
Ma'am, no need, ma'am.
No NEET. What about
I
Prajesh?
just give an attempt, but uh,
Okay.
J.
Okay.
J,
Actually, yesterday I was seeing the NEET paper.
it was also
NEET
mentioned.
paper, everything. See, that is the rule. You cannot deviate. We cannot deviate. NTA cannot deviate because already there is so much of problem with the acceptance of NEET all over the country. One word could not from outside. Not even a single question from outside. The only thing that you needed was the awareness about the whole syllabus, number one. Number two, quick response, particularly when it comes to numericals. Quick response, that's all. Quick calculation. Chemistry can be finished in half an hour. That's all, if you are very quick at calculations. Similarly, those who are targeting the JEE mains, NCRT is the key. 11th and 12th NCRT. Conceptual thoroughness you need. Conceptually understand and work on it. And do the previous year. See, I've been seeing like, no, like when my son was about to join, he's currently doing his MTech in NIT Calicut. Okay. So we were going through a number of videos to browse about this NIT, that NIT, Surathkal NIT, Calicut NIT, Trichy NIT, and so on. Okay, or IIT Madras, etc. And very first statement, chemistry is about NCRT. Even those who have entered, that means they would have cleared advanced. They are also talking about NCRT. NCRT of chemistry. Chemistry, physics and maths, I can't say that. But chemistry, NCRT should be thorough. Conceptually, you learn and you should be thorough about it. Not your memorization is there. A number of places you need, like what temperature, what is the catalyst, a specific catalyst, etc., etc. Memorization is partly there. Okay, but say for example, here you are talking about Sandmeyer reaction where you are using Cu2 Cl2. Okay. Whereas in the fourth lesson, we will see something called as Gattermann reaction doing the same diazonium chloride to chlorobenzene or bromobenzene. There we will be using copper and HCl. So the same, it's replica of Sandmeyer reaction, but with a different catalyst. So you need to know what temperature, what pressure, what catalyst, what is the process, etc. That's all. Not even a single word was outside of NCRT. That is what they say even in mains. Mains is not about everything about NCRT, but concepts are from the NCRT, only NCRT, nothing more than NCRT. So please pay attention, those who are targeting that also. Okay, 2-methyl 1-propene. So 2-methyl 1-propene. Okay, why I'm writing this is the bond line notation is an easy way to represent. You will save a lot of time. Be it JE paper or this paper or any other paper, no, it will save. 2-methyl 1-propene. See, propene, and on the second carbon methyl. So this is propene. This is propene. 3-carbon double bonded structure. On the second carbon, a methyl group. 2-methyl propene 2. 2-chloro 2-methyl propane. So it's 2-methyl 2-chloropropane. There is a methyl, there is a chlorine also. So does it not look like there has been an addition reaction? If you expand it out, you don't need to do that actually, CH2, but still you have to start looking through the bond line notation for the structures. See, it looks like the double bond has been saturated by adding something. There is an extra hydrogen, there is an extra chlorine. So what do you want to do? What do you want to do? How will you convert? Is it not simple HBr HCl addition? The hydrogen goes to that carbon which has got more hydrogen. Cl minus goes to that carbon which has got less hydrogens.
Yes, ma'am.
Okay, so it's simple addition. You just have to add. So HCl, you just have to add. Clear, Pranav and Prajesh?
Yes.
Okay, the next one is ethyl chloride going to propanoic acid, CH3, CH2, COOH. Tell me, this we have already done. Similar cases. Come on.
KCN.
You add KCN in alcohol and then make it into CH3, CH2CN and then do what? Cyanide can be
Hydrolysis.
completely hydrolyzed. This is one Brahmastra. Whenever you want to introduce a carbon, that too in the form of a carboxylic acid, introduce cyanide and hydrolyze, because there are a number of ways for us to convert this back into alcohol, back into aldehyde. Later on, we can take it to ester formation. Number of things can be done with this carboxylic acid. So first getting that is very key, very important. So cyanide the chlorine can be replaced. What if you do AgCN Prameya by mistake? What will the product be? AgCN. Last class we talked about the ambident nucleophile. Remember? If you use AgCN, what will be the product? Pranav? AgC triple bond N.
RCN.
NC, ma'am.
NC, yeah. Because this bond is not ionic. It will not break. So the lone pair attacks. So you will be getting N triple bond C. You don't need that. Isocyanates on hydrolyzed don't give the, what do you say, the carboxylic acid. So take K plus Cn minus. Introduce a cyanide, then hydrolyze. Okay. This was question number 11. Okay. Question number 12. Question number 12. But1-ene to N-butyl iodide. But1-ene to N-butyl iodide. What do you have to do? Is it Markovnikov or anti-Markovnikov? There seem to be some addition. Double bond is no longer there. So there seem to be addition. Okay. Double bond is no longer there. So it seems to be an addition of something. What have you added? Have you not added HI? But is HI addition possible? Is this Markovnikov or anti-Markovnikov product? Markovnikov or anti-Markovnikov product? Tell me, children. H part goes to this carbon and I minus going to this carbon. Is it Markovnikov or anti-Markovnikov? Ennamma? Am I audible?
Yes.
If a H, I looks like that, no? The double bond has gotten saturated. Plus there is I minus present. So I minus has gone to this carbon. Looks like H has gone to this carbon. Is it It is anti-Markovnikov. But last class I told you that anti-Markovnikov works only with HBr. Remember, Markovnikov will work with anything. But anti-Markovnikov does not work excepting for HBr, nothing else. So what you will do is first introduce Br and you get a bromo compound. So the straight chain bromide. And then how will you convert a bromide into iodide? What is the name of the reaction? Bromide into iodide. Bromide into iodide. Check this. How will you convert an RBr into Ri. What is the name of the reaction?
Finkelstein.
Finkelstein. Okay, so today I will do it. Okay, today I'm doing, but I'm expecting you all to learn this lesson fully. Fine. So treat it with NaI in the presence of dry acetone.
Sir.
Don't take a break. Otherwise, this lesson will not go in. Subsequently, all lessons will become a problem. So please do, before you come for the Wednesday's class, please break your head, learn this. And if you have doubts, please contact me. I'll again teach. Fine. 2-chloropropane, 13. 2-chloropropane, 1-propanol. I want OH here. Think about it. I want to remove the Cl first. How do I remove something? Is it not elimination?
OH.
Is it not elimination? Alcoholic KOH. What does it do? Or sorry, concentrated sulfuric acid. Okay, sorry, this is Cl only, no? Concentrated sulfuric acid dehydrates. So that was for opposite direction. So here we will use alcoholic KOH, which acts as a base. So what will it do? It will take a proton from the beta position and remove the halogen. So you get propene. Now, what do? You simply hydrate, but simple hydration will again go for the Markovnikov product. So again add HBr in peroxide and get the bromine here and then do aqueous NaOH. Here did I write the peroxide? Yeah, here I have to write peroxide. HBr in the presence of peroxide. Is this clear? Is this clear?
Yes, ma'am.
Aprameya, Rajesh?
Yes, ma'am.
See, if you want to master this, I'll send the PPT right away. So you please check that this is around some 60th slide onwards. So you can go through it. But after that, please shut it down and redo these questions once again. Try to see how much this is also called, there is some technical name given to that way of learning. What they say is, what they do, what they are asking you to how to learn is basically that I'm given some content. Okay, say for example, I have got some reactions. Say Finkelstein reaction, I have to learn. Okay, Rx plus NaI gives Ri plus NaX, and it could be chloride or bromide, and we are using Le-Chatelier principle, and we are using dry acetone. All the informations are there. Now keep it open and write down the notes. Okay, and think that yeah, I have learned. No, that's not the right way to learn. Okay, like no taking the notes. Okay, I've learned. So let me write and see. Okay, Rx. I'll refer to the book. Oh, Rx. Oh, Cl can be what? Oh, chloride and bromide. Okay, it can be chloride or bromide. Then what will I treat it with? Okay, NaI. I'll treat it with NaI. What will I get? I'll get Ri. Plus, what is the byproduct? Okay, NaX. What is the solvent used here? We'll use dry acetone. This is not how you should learn. What you should learn, how you should learn is you look at the content, understand it thoroughly. Okay, look at the content, understand it thoroughly. Try to recollect that in your mind. Okay, then close it and try to rewrite without looking at the book. Now you will miss some things, right? For example, you remembered that the halogen here could be chloride or bromide, and you are aiming at the production of Ri, and you know that it is NaCl or something like that, but you don't know what to use. Should I use iodine? Should I use NaI? What is it that I'm going to use? So if supposing you don't remember this, then you go and open the text. First, you have to break your head. Okay. See, I remember that there is NaCl. There is no Na in the reactant side. So probably it was NaI. Then you go and ensure that, yes, I am right. And don't do this for a small section. Supposing you're learning let us say we are accumulating the Finkelstein and Schwarz reaction. Remember all the 4 metal or non-metallic halides that can help you. And once you learn both the content, then you go and write. So what will happen is they say that when you keep doing this, like if you want to make your arms very strong, they say you exercise, correct? If you want to make your legs, hamstrings strong, you make a lot of exercise, right? You do a lot
Yes.
of exercise. How will you exercise your brain? How will you improve the performance of the brain? This is how. You give it the work. You are giving the work. Okay, supposing I'm lifting, I'm right now, I'm doing a very gentle work. I'm writing. That's all. My muscles are not getting strained here. Okay, so my arms will not be very muscular. But supposing I'm doing very muscular work, what will happen? Involuntarily, my muscles will become strong. My muscles will automatically become strong. Why? Because my muscles have been put into that work. Same way, learn a content, say 4 or 5 reactions, and then at least 2. You start with two reactions. Understand the purpose. Okay, understand the meaning, everything you understand. Shut it down and try to write. So when you strain yourself to pull the information out of your brain, you are exercising your brain. But if you think, yeah, I understood the class, and at any point of time I will be able to recollect these issues, it will not happen. Clear, children? So I'll suggest that today itself, right away, today itself, go after this class, grab 1 hour for this work, relearn all these conversions, try to get the ideas, what ma'am has done. Could this be the other way? You also think, start thinking. And then close everything up and take a fresh notebook, take the questions fresh, start solving it on your own. You will remember at least 50%, 70%, 80%. Whatever you have not remembered, that alone you go and refer and then acquire it once again. Please do it. It needs that. Okay, so we have finished up to 1 but 1 into N-butyl iodide, I believe, right?
Ma'am,
Yeah,
my computer is having some problem. Can I rejoin?
yeah,
Um,
yeah.
yes, ma'am. Thank you.
Okay, this was 13th. So we have to do 14th one. Okay, 14th is isopropyl alcohol. What is iso? Remember, if you have CH3, CH2, CH2OH, then it is N-propyl, no branching. This is said to be N-propyl. If you take out the last carbon and put it on the last but one, that becomes iso. That means it is a 3-carbon structure, but with the last carbon attached on the last but one. This is your iso. Fill it up with the hydrogen, CH3, CH, CH3. So this is my isopropyl alcohol and I need to convert it to CHI3. Currently, let us not worry about it because this content comes from somewhere in 3rd lesson. Okay, you simply have to treat it with, if you want to remember, NaOH and I2 followed by H plus, that's all. Adu kuda venda. NaOH and I2 will give you. But this is out of context question, so leave it. Okay, next one. When we come to third lesson, we'll do it as iodoform reaction. Coming to the next one, the 15th one. 15th one is chlorobenzene to paranitrophenol. Chlorobenzene to paranitrophenol. Para 1,4 relationship. Paranitrophenol. OH. Is this not from the last section of your text, children, where you were able to do the nucleophilic substitution? If you had the nitro group attached, was it not becoming easy for you to do the reaction if there was a nitro group attached? Children, remember this case? This discussion you remember? Yes? So make the use of this and tell me what to do. Pranav, think. Rajesh, also think, please. What to do? If there is a nitro group, the substitution of the chlorine with an OH is easier. Think about it. Pranav.
Nitrogen.
First you do nitration. So take concentrated HNO3 and H2SO4 and do the nitration. Okay, Cl and NO2. Now, what is the condition? You can use NaOH at 443 Kelvin, no temperature or pressure condition, no pressure condition. And after that, you acidify. Acidification is very much important. Otherwise, you are going to get the sodium salt of it, NaO, Na. So, which we don't want. We want OH. So, to convert O minus Na plus, we are doing acidification. Okay. Is it fine? Yes, Prajesh, Aprameya, have you joined? Hasn't she joined? No. Prajesh is not there. Pranav?
No, I think Rajesh left.
Okay, let him come. Okay, then this is done. Then 2 bromopropane to 1 bromopropane. This is the usual one. The 16th one is a usual one. What is that? 2 bromo to 1 bromo. So simple, treat it with alcoholic care. Sorry?
I think all the others left.
Yeah, no, Ishan is not in town. So he asked me to record. Ah. And Aprameya left because of the problem in her laptop. So she will join. So you get bromine. I'm recording the session, right? So alcoholic KOH will remove the HBr. Yes, Aprameya has joined.
Yes,
Ah.
ma'am.
Yes, ma'am.
So let us hope.
Sorry.
And then you do HBr in the presence of peroxide. Is that fine? 2 bromopropane to 1 bromopropane, ma. Okay? Easy? The 16th one. 17th one. 2-chloroethane to butane. It is very, very simple. CH3Cl2 chloroethane to butane. What do you have to do?
To Na.
That's all. 2 times Na and dry ether. Because you want to protect the sodium from reacting off with any moisture. So you use a protect solvent. Okay. So we will just simply get this butane. Yes, Pranav, clear?
Yes, ma'am.
Okay. The next one. The 18th one. What was that? Benzene to diphenyl. Think about it, children. Benzene to diphenyl.
Phenyl is like OH, right?
No, phenyl. Diphenyl.
Phenyl.
Okay, I'll show you the reference. Yeah,
Oh,
problem
sorry, it's
children.
phenol is OH. Sorry.
Phenol is OH. Diphenyl. Reaction with metals. See. Content படிக்கணும். By content படிச்சிட்டு, then we will have to. So by Wednesday, please do it. Go deep, dig the book completely. Otherwise, what happens? Subsequent lessons will be a build up on this lesson. In the lesson, comfortable illana, அடுத்தடுத்த lesson will become little difficult. Little illa very difficult. You will not remember. Did you prepare the chart that I told, Aprameya? 4 charts varno, 4 varno.
I need to do. I did only
Preparation of RX, preparation of ARX, properties of RX, properties of ARX. Yes, Pranav?
Yes, ma'am, I do.
And at one glance, you should be able to see everything. You will be able to see everything. Okay, please do that. So diphenyl பண்றதுக்கு என்ன வேணும்? You want to make diphenyl. Diphenyl பண்றதுக்கு
Doing.
we will do phytic. But phytic பண்றதுக்கு first we should have a halogen, na? So do we have a halogen in this? The benzene.
No, no. Can we do halogenation and then do?
Cl2 in the presence of FeCl3 and you make the appearance of the halogen first, the Cl. Once you have the Cl, then you use 2 moles of sodium dry ether and make the diphenyl ready. Don't think, ma'am, inga 1 mole தானே இருக்கு அப்படி இல்ல. Even if it is 1 mole, half a mole will react with another half a mole and you will get half a mole. So it's not balanced chemical equation, no children here. Though they are giving you 2 moles, in conversion you don't have to write or you write nothing wrong. You are not presenting a balanced chemical equation when you are doing conversions. Clear?
Yes, ma'am.
Okay. Right. Next one. So that is done. Tertiary butyl bromide to isobutyl bromide. Tertiary butyl bromide, CH3, CCH3, bromo. And you are going to get isobutyl bromide. What is iso? Remember, this is N-butyl bromide. If you detach a carbon and attach it on the last but one, it becomes iso. So that means it is CH3, CH, CH3, CH2Br. Think about it, both of you. What can be done? See, look at the carbon chain. Nothing happens to the carbon chain. By and large, it is the same. I don't want the see, look at, if I put it like this, will it help? See, CH3, CBr, CH3 and CH3. Will it help? This to this. You want to shift the position of the
Can
Br.
we remove Br and then add it?
Yeah.
Yeah.
That's all. So
Oh.
number one, what you will do? Alcoholic KOH. What will you get? If you are treating it with alcoholic KOH, let us do it here. Alcoholic KOH. I'll put it like this so that it becomes comfortable. BrCH3 and CH3. Alcoholic KOH. It will introduce a double bond here, right? And subsequently, use HBr in the presence of peroxide. So you add H to the carbon having no hydrogens or less hydrogens, Br to that carbon which has got more hydrogens. Is it clear?
Yes, ma'am.
Okay. Right. This aniline to phenyl isocyanide is also something that we will do in the 4th lesson. Okay. We'll do in the 4th lesson. Okay. There is a special reaction for that. Okay. What we will do is we'll quickly do one reaction. This one, 6.21. 6.21. I'll expand the page. For this today's class, I'll do this problem. 6.21. Try to read it. First, you write what you do, no, both of you. You make a flow chart. For example, what is a flow chart? What is a flow chart going to look like? A flow chart looks like this. Say I'll tell you that a compound A, a compound X on treatment with NaOH aqueous is becoming compound B. Compound B on treatment with SOCl2 becomes compound C. Compound C on treatment with sodium is going to give me ethane, CH3 single bond CH3. So this is said to be a flow chart with the given hints. As the question reads, you try to make a flow of the reactions. Please do that first. ஒரு தடவை படிச்சு பண்ணி பாருங்களேன். Please do that. And if there is some hint provided, write down. Primary alkyl halide C4H9Br is called as A. Okay, it's not A subdivision. This compound is labeled as A. C4H9Br is labeled as A. Reacted with alcoholic KOH to give a compound B. Make a flowchart of this, both of you. Once it is done, please let me know. Is it done? Yes, Ma, is it done?
Yes.
Pranav, doing it?
Yes.
I have a doubt. And is it kind of, it's kind of silly. Where when we react something with KOH, which hydrogen is removed? Like the beta
You
one.
get a ZZF product. ZZF product is the double bond will be more substituted. Remember?
Yes, ma'am.
So supposing you have a halogen here, Br, and if you are doing alcoholic KOH, then most likely the hydrogen from the crowded place will go so that you get a more substituted double bond. If the hydrogen from this position is taken off, then you will get the double bond on the last position. That is not a more substituted alkene, na?
Yes.
Okay. Shall I do it now?
Yes, ma'am.
Okay. Pranav, shall we start?
Yes.
Okay. See. See, as I read, I'll start making primary alkyl halide C4H9Br. So C4H9Br. Need
Can
some
we
space.
assume it is linear or we can't do that?
No, and let us see. C4H9Br is A. Fine. Okay, it is primary. So what are the two primaries that you can make from this? இப்பவே பண்ணி வைங்க. There are two primaries that is possible from this. Tell me what are they? Or there is only
N,
one.
N bromo.
N
maybe.
bromo is one. One more. You can take this and put it on the last but one. Na? It becomes iso. Even that is. Even this is primary. The carbon containing the halogen is further connected to one more carbon only. Remember? So either it must be this one or this one. Okay. Fine.
Yes, ma'am.
Okay. So C4H9Br A is reacted with alcoholic KOH. So alcoholic KOH will remove the HBr. So let it go. Okay. So HBr, once the HBr is gone, it will become C4H8 because HBr is removed off. So we get this as B. Okay. Is reacted with alcoholic KOH to give compound B. Compound B is treated with HBr again. So again it is, so this is an alkene. Na? From an saturated halide, you are removing the HBr. That means this is an alkene and you are adding again an HBr. So when you add an HBr, it goes by Markovnikov rule, right? So supposing we don't have to treat this, we'll update pola, then we will come back. So if you treat it with HBr, you get C, which is an isomer of A in runner. C
Ma'am,
is an isomer of A.
unless they mention peroxide, we don't need to worry
No,
about that.
this is Markovnikov only. Unless they say peroxide, you don't treat it as peroxide. Fine. Okay.
Yes.
So it gives C, which is an isomer of A. Okay. When A is reacted with sodium metal, when A is reacted with sodium metal, it gives compound D. So there must be Wood's reaction. Correct? There is Wood's reaction going on. Alkyl
Yes, ma'am.
halide plus sodium metal. Okay. Don't even expect dry ether. No, nothing. Even sodium metal is good enough to identify Wood's reaction. So when it is treated with sodium metal, it gives compound D. Okay. Comma. It's comma or full stop? It's comma. What is the formula of the compound D? The formula of the compound D is C8H18. Okay. C8H18. Right. Which is, this compound C8H18 is different from the compound formed when N-butyl bromide is reacted with sodium. So this compound is different from what you might get when N-butyl bromide is reacted. It is different, they are saying. So what do you infer? Can
It should
this
be
be?
iso.
Yeah, that's all. Can this be the N-butyl bromide? Can A be N-butyl bromide? No,
No.
no, because for compound A on treatment with sodium is giving D, which is different from what you are going to get by using N-butyl bromide. So definitely it is not, the starting material is not N-butyl bromide. So that clarifies. Now, this is your isobutyl bromide, alcoholic KOH. So there is no other place. You have to generate the double bond here. So double bond is generated here. But when you add HBr, where will you add HBr? Hydrogen will go to that carbon which has got more hydrogens, and the Br minus will go to that carbon which has got less. So you would be getting the bromine here. Is it not an isomer to A, children?
Yes, ma'am.
Okay. So what will A produce on treatment with sodium metal? What will A produce on treatment? So you have taken this compound as A. So you write it once again. This is your A. 2 moles of sodium. Remove. So once you remove, what will happen? You remove these and you just have to connect the two. That's all. Okay, don't write the structure like this. Of course, it looks very weird. So it will be like this. Is that okay? Is that fine? There was a bromine here. There was a bromine here. You use 2 moles of sodium. Remove the bromines and connect the 2 carbons. Clear? Aprameya and Pranav?
Yes.
Okay.
Yes.
So this must be D. And where the hint comes from, it says that the D is not what can be
Butane.
formed by N-bromobutane. Yeah. So obviously it is the starting material is not N-bromo, and hence it must be isobrom. Is it okay?
Yes, ma'am.
Okay, right. So please take this as a task on you. Focus on this lesson. In the lesson thorough பண்ணிட்டு அடுத்த lesson போனாதான் many reactions will be quoted from the first lesson. When we go to third lesson, first 2 lessons will be quoted. So please
Yes.
spend time with this lesson and redo these questions once again. Clear? Take a picture of this question. Take a picture because it is not on the PPT. Okay? Shall we end the class?
Yes.
Any doubts, ma?
Yeah, I'm not still sure how to find the substituted carbon. I'm struggling with it.
Substituted what?
Sorry, hydrogen, substituted hydrogen.
See, okay, you have that out, no problem. See here, if supposing we have got the 2-bromo butane. Okay,
Yes, ma'am.
above, this is alpha, this is beta 1, this is beta 2. So if
Yes,
you treat it with alcoholic KOH, Apo you can remove the hydrogen from beta 1. Apo double bond inga form aguma.
yes, ma'am.
அப்போ ஒருவேளை பீட்டா 2ல இருந்துன்னா இங்க தான் டபுள் பாண்ட் ஃபார்ம் ஆகும், ரைட்?
Yes, ma'am.
ஓகே ஓகே. இங்க என்ன இருக்கு சொல்லு? இதுதான் கார்பன் ஃப்ரேம்வொர்க். ஐ அம் கோயிங் டு யூஸ் another color. இங்க என்ன இருக்கு? இங்க என்ன இருக்கு? ஹைட்ரோஜன், ஹைட்ரோஜன்.
CH.
இங்க என்ன இருக்கு? ஹைட்ரோஜன், ரைட்?
Yes, ma'am.
ஓகே. இங்க என்ன இருக்கு? இது கார்பன்ல.
Yes, ma'am.
What is the other one here? Nothing is mentioned, so hydrogen. Here also hydrogen and here carbon. How many hydrogens do you see in the second compound?
2.
How many hydrogens? Don't count all these.
Oh.
These are useless.
Yes.
நம்ம பார்க்கிறது இந்த 2 டபுள் பாண்டட் கார்பன் இருக்குல்ல, அதை மட்டும் தான் நம்ம பார்க்கணும். இந்த கார்பனையும் இந்த கார்பனையும் பார்க்கணும்.
Yes,
இந்த
ma'am.
கார்பன் and இந்த கார்பன். மத்ததுல எல்லாம் இருக்கிற hydrogens are not counted here.
Yes,
So
ma'am.
there will be so many. இங்க பார்த்தீங்கன்னா CH3 இருக்கு. CH3 இருக்கு. So double bonded carbonsல எவ்வளவு directly attached hydrogens are there in the first case?
2. The first case 3, second case 2.
அவ்வளவுதான். So this becomes more substituted because hydrogens are missing.
Missing. Okay, less. Fine. Yes, ma'am.
Understood? Say supposing I have got this case. Say iodine is here.
Yes,
Yeah.
ma'am.
So this is alpha. Na அதை சுத்தி இருக்கிறது எல்லாமே beta. இது
Beta.
பீட்டா, இது பீட்டா, இது பீட்டா. இந்த 2 பீட்டாவும் ஐடென்டிக்கல். அதனால ஏதாவது ஒண்ணு கன்சிடர் பண்ணா போறோம். அப்போ ஒருவேளை இந்த பீட்டா 1ல இருந்து இதுவும் பீட்டா 1 தான். அதனால தான் ரிப்பீட் பண்ண வேண்டான்ற. சோ ஒருவேளை இந்த பீட்டா இன்வால்வ் ஆயிருக்குன்னா டபுள் பாண்ட் எங்க ஃபார்ம் ஆகும் பாரு. இட் will be formed here. இது மெத்தில் குரூப் அப்படியே இருக்கும். Iodine went and hydrogen also went. Fine?
Yes, ma'am.
ஓகே. அப்படி இல்லைன்னா பீட்டா 2னா இந்த ஹைட்ரோஜனும் இந்த அயோடினும் போகணும். அப்போ டபுள் பாண்ட் எங்க வரும்? ஆல்பாக்கும் பீட்டா 2க்கும் நடுவுல வரும். ஓகே. இப்போ பாரு என்ன ஆயிடும்? இங்க என்ன இருக்கு? இங்க ஒண்ணுமே இல்ல. அப்பனா இங்க ஹைட்ரோஜன் ஹைட்ரோஜன் இருக்கணுமா? இந்த கார்பன் மேல என்ன இருக்கு? கார்பன் அண்ட் கார்பன், ரைட்?
Carbon. Yeah.
இங்க என்ன இருக்கு? இந்த கார்பன் மேல கார்பன் அண்ட் கார்பன். இந்த கார்பன் மேல என்ன இருக்கு? கார்பன் அண்ட் மிஞ்சி இருக்கிறது ஒரு ஹைட்ரோஜன். அப்போ which is having less hydrogens and more carbons. அப்போ அதான் more substituted product.
Yes, ma'am. I understand. So in the exam we can write both the products and then
This is major and this is minor. Okay?
Okay, ma'am. Thank you, ma'am.
Oh, yes, ma'am. Pranav, any doubts?
No, ma'am.
Okay, படிங்களா அந்த லெசன் படிச்சுட்டு வாங்க ப்ளீஸ்.
Yes, ma'am.
ஓகே
Yes.
Thank you.
ஓகே பை பை.
Thank you.
ஒரு விஜய்